Thank you very much again for coming to TiEcon, and welcome to this new session that focuses on commercial applications of big data. My name is Harikesh Nair, and I'm a professor in Stanford Business School. And it gives me great pleasure to introduce our very distinguished panel. So the goal of the session is to give you an introduction into various verticals in which data and analytics is having a huge impact. Our moderator is YY Lee, who is the Chief Operating Officer of First Rain. It's a company that focuses on personalized business intelligence using unstructured data. Thank you very much for hosting this, YY. We also have a very distinguished panel here. Zachery Anderson, who is sitting to my right, is the VP of Marketing Analytics at Electronic Arts. Anil Varma, who is sitting to his right, was until recently the head of data science at General Electric's Center for Excellence. And Guy Halfteck, who is on the extreme right, is the CEO and founder of Knack, a very exciting company that is focused on using big data for workplace analytics. So hopefully this will give you a cross-section of applications of big data in a wide variety of verticals. So please join me in welcoming this very distinguished panel.
Okay, well, this is really exciting. We have 30 minutes. It's really fast, so we're going to try to get to as much discussion as possible. But before we get started, just so we know who we're talking to, how many people here are from the technology side and are working with software or data? Very, very technical crowd. Very cool. Okay, how many people are from the business side trying to make money? Technology people, you should be trying to make money too. I'm technical, but I focus a lot on making money for my company. Okay, how many people from Silicon Valley? Big local crowd. Outside of Silicon Valley came here for this conference. Wow, this conference is a huge draw. That is fantastic. So I was just talking to Anil before we started about how the progression that has led to big data, information science, being at the center of a lot of technology development and differentiation kind of mirrors the development of the Valley. I've been in the Valley for about 25 years. And in the 90s, it was all about electronics. There was huge revolution in electronics, which was enabling major changes in the world. In the 2000s, it was all about connectivity. It was all about everybody getting online. And what that led to is now in this decade, it is all about information. There is information everywhere. There's this incredible digital exhaust, right? It leads to companies like mine. What we're doing is, we make an MRI machine. We look through all of that digital exhaust on the global and social web, and we build in real time a structured model of what's happening inside and between companies, because companies are not trying to tell you about themselves, right? So that's one example. But we have so many great examples here of other commercial applications. Everything from the far industrial applications, GE, which is such an established company, but is at the leading edge of intelligent machines, Internet of Things, and trying to use the information and the connectivity to change the way we do business in the physical world, all the way to Electronic Arts, makes games that we or our children have all played, to Guy, who is working at the leading edge of gaming and trying to apply data to make behavior and data-driven games. So this is really, really exciting. So maybe I'll start out by asking my panelists, can you describe one particularly interesting problem that you and your teams are working on solving? Maybe surprising, because everybody talks about personalization and all of that. What is one problem that you and your teams are working on solving today that might shed some light on the kinds of things that we can address using data science, information science, data analytics?
We're spending a lot of time right now thinking about how to use cues from our players in the game to propagate training materials for them so that they can get better in the game in real time that are personalized to their actions. So really interesting, even on some of our websites and other activities, to be able to deliver, like you in FIFA, you were shooting from the wrong place, or you were too slow on the pass button, those kind of things that are really personalized to how the player's playing to help them improve. When you play games, you want to get better. That's part of the fun of it, is mastery. And so we want to really invest in helping people master the games in better ways and giving them help that's personalized to what they're doing.
All right, so my interest is on the industrial side, so I'll give you an example from maybe the jet engine space. So one problem that we looked at is one of our latest jet engines that spits out about 0.5 terabyte per flight. When it reaches a particular altitude and happens to be in a particular atmospheric condition, exhibits a behavior that we did not anticipate. So then the question is that because of the engine? Is it because of the atmosphere? Is it because of the way it was flown? Was it because of the way it was maintained? So you really have to take all these sources of data, align them, and try to figure out the answer to that question. So that just gives you a sense of the kind of problems that we look at.
Hi, everyone. Great to be here. Hope you can hear me well. So what we're doing at Knack is actually trying to understand people in a fundamentally new way. So we're building models of people, models of human behavior, and trying to use games. We're using games, mobile games. I just downloaded our new mobile app that is going to be available to everyone in about 2 weeks. But we're using those games to change the game in how we understand people, how we predict behavior, and how we provide insight to people.
So, one question is, you're all thinking about such different types of problems, but there are some really common challenges, right? So everybody likes to talk about, for example, I know that when my team talks to me about a new problem they're going to solve, they always have like the idealized view, like, oh, and then we're going to analyze this data, and then all of a sudden we're going to have this perfect model of how companies behave in this situation and how they interact in that, because they have kind of an idealized view of a data-rich environment with, little ambiguity. And as we all know, when you start getting into it, there are kind of a million corner cases. So I'm really interested in some of these problems that you're solving. For example, in the gaming space, where you're modeling human behavior and when you're modeling player interactions, or in the machine space, right? How much of the data, and how do you deal with it when there are things that are clearly causal, right? It's like, oh, if I could just aggregate this data, of course it means X. But my experience is that much, much more of the time, we run into situations where the meaning of the data is actually not entirely clear, or perhaps, yes, the data would be very clear, but in many situations, the data is too sparse, or it is too inconsistent, or the data comes inconsistently from different areas. So how do you deal with the realities of kind of these big problems that you're trying to solve, and kind of where have you run into that, and what's really worked for your teams?
So, I think there's lots of those problems. That's the classic case of, people, the one that I see a lot, especially when we used to focus more on ad hoc work, is, a leader in a company asking for a piece of data, thinking that it would answer a question, and no good context around it, no, understanding of that. And usually most of the leaders of the company don't really understand the data they have, so what they ask for is the wrong piece of data. But, what I find is that the solution for that we've, what we've found, especially as you transfer from using aggregate data to individual level analysis, is it's all about the cohort of people that you're selecting. The data becomes much more actionable when you understand who it is that you're looking at, as opposed to using average. In our space, and maybe a guy can comment on this, but in our space, we have really extreme behaviors. People play our games for thousands of hours, or for 5 minutes, or for 1 day. And really trying to say, all right, who is the cohort that we're looking at? What is the behavior we're trying to understand? And getting down to knowing the customer or the player, and then starting to ask your questions solves those problems almost all the time. It's when you look in average and you're trying to say, we've got 20 million people playing FIFA, why do some of them leave? Like, that's an unanswerable question. It's why did the people that left this day leave? That's an answerable question, and also one that you can actually act on.
Right, and I think that's a really interesting distinction, that there is this big distinction between trying to understand aggregate patterns versus trying to actually use data to systematically understand each individual, and then perhaps the system taking action based on that. individual.
Well,
I know,
that's a separate question. Actually, taking action is the next piece.
Right, right. And Zach, you guys are, I'm sorry, Guy, you guys are right in the middle of that, right? Not only
right.
building a model.
So what we're doing is, I think it's important to realize that the opportunity in data is actually hanging very low. Even if you start with limited amounts of data. And we have a vision, as YY said, about a world that is eaten by data, and there is data everywhere, and data is available for everyone, and that changes experiences, products, decisions, you name it. But I think we're starting small in terms of there is data that is available, and it already helps us, delivers significant business value without trying to boil the ocean. So I think that's a very important lesson that we're implementing and keeping front and center every day. So we're building models that are not the most sophisticated models that we'll build, say, in a year from now or 24 months from now, but those models apply across very large cohorts and help us understand both individuals and find patterns and help people and companies make much better decisions. So we already see the ROI on that. And as we go forward, we'll make many more models. The models will be created on the fly, and we're going to have many more variables, and we'll be able to understand in a much more targeted way different people in different environments and model different behaviors. But we're starting with the lowest hanging opportunity. And the reason being is that as we feed to the market, to users, those tools to make better decisions, our ability to then close the feedback loop and get the data will enable us to build even superior models. So I see this as exponential curve of the data and the feedback loop into building additional models that will increase over time.
That's great. And Anil, at GE, it would be great to understand, because GE talks about these huge systems, right? So you have visibility over these enormous aggregate systems, but of course you also have to keep individual machines running. And so what's the difference between answering those types of questions? Are there different techniques?
Sure. So I think one thing that's different about industrial is you don't have millions of anything, unlike consumer and retail. You have a lot of complexity, but you have maybe 400 airlines, you have 6 North American railroads, you only have so many utility producers. So you don't have scale in that dimension. But to give you a sense of where the opportunity is, I'll take a train example. The leverage you can get from analytics and data is huge. So imagine a train running on a train network, and a locomotive dies. Now, that particular assignment it was on has failed, so you're going to pay for that. You've also clogged the network, so no other train can cross the track, so that's going to cause cost. Now you have to find another locomotive from somewhere else, and you have to send it to push that train out of the way to the closest repair track, so that's going to cost. And then you have to fix it, and then put it back on the track. And then it has to try to recover both its mission as well as whatever it was carrying, and if it was carrying stuff that is temperature controlled or time constrained. So just look at the multiplier effects of all the costs just because of one thing that if you could have predicted and maintained it or prevented it from failing. So I think that's the difference. You don't have the millions of transactional scale, but any given transaction can be extremely valuable if you can make a difference.
So I want to make a quick point here, and I think when we're talking about big data, so the 3 V's, the volume, variety, velocity, I would add a 4th one, which is value. And it's not necessarily, and the weights I would assign to each of those variables in our big data definition is not equal. So I'd rather have higher value data coming at a lower volume, at a lower velocity, than have a high volume of very low value data. So back to Anil's point. And I think it's an iterative process of figuring out actually where is the high value of the data. Not every bit of data is as valuable, and not all data sets are created equal.
I think one of the things that I notice now, at least I've seen in our company and our industry, is that the problem is that there's a lot of ways to make use of the data. We're on 2.5 petabytes or something like that at EA. We have a lot of data, but the problem is actually that I can generate insights from the data faster than the company can act on them. So with a relatively small team, with the tools that we have in place now and the accessibility of the data, the problem isn't that can I make cohorts to personalize a message to an advertising, or tip and trick to in a game. It's how fast can I actually get that in the game? How fast can I get action on it? And it's the insight to data side now that's lacking. It used to be our ability to gather insights from the data was hard. That's easy now. Well, relatively easy. It's taking action fast enough and then taking those actions at scale. So the question when you want to personalize an advertising campaign, like that's great, I can build cohorts out of our big database of really people that we know well and that we want to offer a pricing message to or something like that. But can I actually implement 20,000 cohorts and offer different messages that are tailored to all of them in a fast time without increasing the headcount of the company? That's a really interesting question that we're failing at right now, I think, as an industry, is we're still focused on the hardware and the solutions to find insights, but really when you start to cohortize and build really small segments which allow for really personalized high response rates, which we all know work, how do you actually deploy those at scale? And that's the really interesting challenge.
I think that's such a good point because up until now, because data science and information science is very young, up until now, a lot of times it's been bundled into the software or the product cycle. And that's actually something that my team has recently realized, which is, we can generate insights, we can get new types of data, new types of high volume or high value data, but you don't want to wait for the product to actually have to be updated to make use of that. And so one of the architectural decisions that we're seeing in software in our own platform and in other companies that are doing very leading edge things with data is this separation of this architectural separation where the software platform, the behavior of the product is architected in such a way that you can make massive, very, very fast, very flexible algorithm changes. And let's say you have new notifications, new insights, new tips and tricks, new error conditions, right? New types of data that may come in, that you can actually onload that onto the system without changing the product platform itself. And that is, I think that's an example of how the data science piece is actually coming up in recent years to be as much of a technology platform as the product or the software platform. So that leads me to my next set of questions, which is, I think there's a lot of entrepreneurs and intrapreneurs in the audience who are looking to solve big problems that are high value. So when you look from the technology side up, what are the problems that you would like to see solved? What are the things that are not done well today? Because we know we are just at the beginning of leveraging this stuff, right? So where are the opportunities to solve big problems or big gaps that would move the needle in your application spaces? Maybe Anil from the industrial side.
So I'll talk about a couple. So I think from the machine learning side, this notion of models that will make decisions, but they will also know when not to make a decision because of either bad data quality or they've gone into a region where they really should not be making a decision. So how do you deploy models at scale without needing someone to handhold the models and watch over them? So I think that's a very interesting technical issue for us. The other one I would say is I think the biggest way to get from big data to small data is for a person to understand the data. So how do you do more work in the human-machine interface when people running critical infrastructure, making high-value decisions? They're going to have a lot of data coming at them. But at least on the industrial side, there's always going to be a human in the loop making the decision at the end. And the more we can do to reduce the friction between what's actually happening in the data and what someone should be taking away from that data, I think is a rich area for research.
I think some of the biggest challenges today, and where I think things are going to unfold soon, is thinking about the data-human interface. So there is richness of data. There are insights and models everywhere, and companies can shove at consumers and customers and users tons of data and analytics. I think that actually misses the point. The point is, and we're trying to avoid that at all cost. We don't want to give users data because users don't know and don't need actually the data itself. They need better experience, they need better product, they need better decisions. They want to have their experience and whatever they'll do, discovery and so forth, be better suited and personalized to who they are. So I think that the biggest challenge is actually finding a seamless way to integrate data into products, into experiences, making the products human adaptive. So I envision basically a huge opportunity in human-aware computing that is aware of a specific user in a very fundamental and deep way and alters the product and the experience on the fly, coupled with insights, decisions, recommendations, personalization of every aspect of that product. And going beyond products of those that we see today, recommendations engines or other things, I think it's going to be much deeper and extensive, go into many other experiences around us.
Yeah, I mean, I think what Guy described is exactly what the type of things that we're working on and trying to solve. The other thing that I'd say in the advertising space in particular is, you know, there's lots of work being done on multi-channel attribution and on trying to connect all the advertising activities and figure out which ones are working. There's not as much work being done right now on how to actually act on that rapidly across the channel and to really use personalized campaigns. So there are, you know, companies that will help you execute personalized campaigns, but they're not really using attribution data to do that. You have to specify the campaigns themselves. And so I think, how do we get so that a small number of users, as I mentioned before, can actually execute a huge number of personalized campaigns across lots of different channels in the advertising space is really the next step that will allow the companies to reach more things. We literally have to hire more people just to execute more campaigns as opposed to being able to use the technology for it.
That's great. Yeah, so some really target-rich areas for next-level innovation, right? So now we have all these tools. We can generate all these patterns and insights, and there's kind of too many for people to absorb, right? So there's a real innovation layer that is waiting. And then also, Anil, what you were saying is a meta-level intelligence, right? In my team, we call those skepticism engines, right? So it's like in the early days of data science, you're always looking for positive match. You know, can I see an indication of this? Can I see an indication of that? And once you get very sophisticated and you start deploying these things out, you actually have to build in systems that are as skeptical as they are good at drawing conclusions, or else you're going to just draw the wrong conclusions. And these areas are just ripe for innovation. There are many people and companies that are going to invent these. So as these problems get solved, as you are incredibly successful at revolutionizing personal experience, industrial networks and things like that, what is the vision that you envision? You know, what's the vision that entrepreneurs that are working in the data science and the software space will be able to participate in, and what will be different about how we access data, how technology runs, accessibility and things like that as we go, maybe starting with Zach.
I mean, for me in the gaming space, and I think in lots of other places where I use technology, I love this concept of flow that was developed a few years ago, that we build experiences where people easily know what to do, the challenges, the things they're doing are fun, are exciting to them. That's the optimization, and the key is the data really allows us to not make those decisions once for millions of people, but millions of times for each person, so that the data is really integrated into how the products deliver to the customers every day. You know, we do that simply in Google Search and Open Graph and those kind of things, but more sophisticated products that can alter themselves to adjust to what the customer actually needs and how they want to interact with it is really the future to me.
Guy, what's your vision of the future?
So we see a very exciting future, and our vision is that, first of all, technology, the face of technology, we think is going to change dramatically, because data will make technology accessible and available to people purely by discovery, to people that today just don't rise to the surface, don't bubble up for whatever reason. So whether it's in workforce, education, access to products, and any other experiences, we think that the data is going to start to change that in a very rapid way. So we see a future that is much more leveling the playing field, using the data to understand people. And, you know, not to be too lofty about it, but if you think about the past several decades, if you think about personal computing and then social computing and mobile, we're moving in a trajectory of understanding people in different circles and honing in and focusing more on the person. I think we're now at the point of behavioral computing and understanding people at a very fundamental and a richer way that was not available before. And I think this is going to change many of the things that we do today and level the playing field in a very fundamental way. So we're very excited about that.
So I think on the industrial side, I would say for a long time, our assumption's been that, we live in an infinite resource world, and then that's just not true. There's not going to be enough oil. There's not going to be enough energy. There's not enough access to healthcare. So these are all finite resources. And when you look at the amount of inefficiency and waste there is in the industrial side, I think that's exciting from if you want to solve a big problem from the data side. Because the more optimization we can easily get efficiencies of 20, 40% over how we operate today. And it's not just unlocking value, but I think it's just being smarter about how we use our resources and make them available to large parts of the world that don't have them, frankly. So I think that's probably the right way to think about why we want to use data science, big data in a good way in the industrial space.
Okay, well, thank you very, very much. What a great panel of speakers.